Welcome back to the second episode of the Physical Geography of the Earth. Here we are looking down on Jurassic Coast. There is 185 million years of history in this coast. Join me as we journey back in time to understand the physical geographical processes that created this beautiful coastline. In the distance you can see Scotland Bay, which was quite famous during World War II, as we shall see later on. We are now making our way down towards the coastline. It is quite windy today. This is a very important geographical point which will help to explain why the coastline that we will now be viewing is actually the way it has formed. Let's get closer as we walk down towards the coast. We have now made our way down to the coastline, looking on at Scotland Bay. In the distance is Scotland and Gollingdon Heath National Reserve. Notice the wave action, and this hydraulic action plays a very important part in the development of the coastline. Looking into the distance, you can see what are called stacks, the white and patchy coloured rocks in the distance. This is called Old Harry rocks, and we shall look on a little bit more on how these were created in a bit. We have now journeyed westward along the coastline to explore the coast some more. Today it's quite windy, as you can see from the grass blowing. Now we are journeying even further down this cliff, heading towards the coastline. In the distance, the famous English Channel that we have discussed previously. But if you look even further down, you can see what appears to be a dinosaur. After all, we are at Jurassic Coast, so let's go on further down to investigate this some more. It appears as though that the dinosaur is lying in the sea, and the tail of the dinosaur is partly submerged in the water. Let's look on some more at the beautiful sea. Hello there, this is Ryan the Explorer. In order to fully understand Dordrecht, we need to go into my cartoon universe. Well, hello, it's Ryan the Explorer in my cartoon form, in my cartoon universe. I've created this universe so that we can better understand the physical geography of the Earth by being able to travel through time and to fly and to do many other things that we can't do in the physical universe. So join me as we continue to explore the physical geography of this wonderful planet Earth. Here we go with Dordrecht, looking in more details about its physical formation. Here we are back in the present looking at Dordrecht, but we must travel back in time to understand its formation. It is an arch at present. However, in the past it was a peninsula, and with the hydraulic action of the water, a crack developed and the crack became a cave, and that cave continued to form the arch that we see today. Let's travel even further now into the future. As the arch continues to weather away under its own weight, it will eventually collapse to become a stack, as in the case of Old Harry. And this stack will erode away to eventually become what is called a stump. Let's return now to our universe, where we can see Dordrecht again in its real form and spectacular glory. It's quite amazing actually, and quite ironic to have a rock formation that looks like a dinosaur at the Jurassic Coast. Let's admire its beauty some more. Again, we can see the waves in action, causing erosion and hydraulic action. Here it is at a higher vantage point. In the distance you can see an island. That island is actually the Isle of Portland, which is connected by a sandbank to the mainland Great Britain. Let's leave Duddledore now as we continue our adventure of Jurassic Coast. Welcome to Lolwood Cove. Let's take a walk along and see what other geographical physical features we can discover. Here we are at the coast and we can see on the right hand side lower down a crack. As previously discussed, the cracks are the first start of the formation of the arches and the stacks. There you go. Hydraulic action in action. There are lots of geographical features here. As you can see, a blowhole in the distance as well as caves. And if you notice on the left hand side, the rocks are quite rippled. This is because this is Purbeck rock, an alternating layer of limestone with shade bands. And this is an example of gravity crumpling the rock because of differential erosion. To better understand differential erosion, let's travel back to the Jurassic Coast, which is located on the southwest part of England. As you can see, this is a stretch of coastline that extends 95 miles from Old Harry Rocks, where we were at present, to Exmouth. Here we can see that it's made up of Triassic, Jurassic, Early Cretaceous and Late Cretaceous rocks, and it is because of these different types of rocks that we have differential erosion and the coastline we see today. Again, back at Lolwood Cove, we can see Walden beds and Purbeck beds of rocks along the coastline along with the chalk. And we need to travel back in time to understand the formation of the cove. Again, Triassic, Jurassic and Cretaceous periods from 255 million years to 205, then 205 to 150, then 150 to 70 million years ago. Here we are looking now at Lolwood Cove. Let's zoom in a bit at the cove and we can now travel back in time. Here we can see the different layered rocks actually exposed to the coastline, and the water erosion takes place, as you can see, at different rates because of the different types of rocks, creating the cove slowly with time. The chalk being much faster to erode away compared to the other type of rocks, and we will discuss a reason why this is the case when we examine the rocks later on to see what they're actually made of. So with time we can see Lolwood Cove forming. Let's take a look now at Lolwood Cove in some more detail. Differential erosion has created this curved structure that you see before me. And in the distance you can see the different layered rocks, the reddish brown rocks and the whitish rocks, evidence of the different time periods from the Triassic, Jurassic and Cretaceous times. Let's have a walk around Lolwood Cove now as we search for rocks to help us to understand it a bit better. Oh, I seem to have found one. Here we go. Here we are now back at my lab where we will look at this rock in some more detail. I have here a very strong magnet which we would use to investigate the iron content of the rock in a bit. In addition, I've got this litmus paper, and number 7, as you can see, is a neutral pH, which is this lightish green color. Let's test this water and see what the pH is as our control experiment. Let's compare it now. So it does appear to be neutral with the same lightish green color. Now let's do our experiment. I've crushed the rocks up here, as you can see, and we will put these rocks into the water. But let's test the pH again just to confirm that it is a neutral number 7 pH. Again, pH checks the acidity of the medium. I'm adding the rocks now, and let's add them, and then here we go. Stir it up now. Here I'm stirring it up. We've crushed it so the surface area can be a bit more, and it'll help with the mixture. Let's take the litmus paper and see what the pH is. I would expect it to be neutral or slightly alkaline because of the calcium carbonate in the rocks along with the iron oxide. It should give us maybe a neutral to slightly alkaline pH, which is a darker green color, which appears to be the case. Neutral to a darker green color, which we expect to see. Now let's leave the pH and examine for the possibility of iron in the rocks. This is where our magnet comes in. I will take the magnet and try to see if it will attract the bits of rock. Obviously it's difficult to attract in the water, but let's look at it here. And as you can see, there is some small attraction on the magnet of the rocks. Let's try it again to get a little bit more of the iron from the rock. And if you can see very closely, there it is, the iron filings of the rock. Here we are back at Lolwood Cove. Again, we can admire the view, and we can fully appreciate in the distance the rippling, as you can see there, of the rocks which we discussed previously, the mixture of limestone and slate. And then we can see the iron oxide rock, the reddish brown rocks there in the distance. And then of course we can admire the view. So here we are back at Doodledore. This is the second episode in the physical geography of the Earth. Just as the coastline changes with time, so too everything changes. We want it to be the change we want to see in our universe. This is Ryan the Explorer saying goodbye until next time.